second.
Our second speaker is Don McCann from the United States, and his background, his biography is already shown, so I don't have to introduce Mr. McCann.
Thank you very much for that introduction. And I'd like to thank the council for allowing me to come in and talk to such a distinguished audience. It's not very often that a glass geek like myself gets to come in and talk to an audience like this. There are a few people I do need to thank. However, when I was setting up this presentation, it was going to take about 45 minutes. And you don't have to worry about it. I'm going to cut it down. There were 3 people that helped me cut that presentation down. Charles Cliff from CDC already talked about some of the glare issues, so I'm not going to go into that. Mr. Poon from Thornton Tomasetti talked about one of the key topics I was going to talk about, which was more glass, less aluminum. And then Dr. Chung mentioned curtain wall systems being a very cost-effective and sustainable way of cladding your building. So I'm done with my presentation, so you can all go. Since I'm here, I will go through my presentation. The presentation is going to be glass. If some is good, is more better. So we're going to go into various topics and discuss those key issues. And as I mentioned, commercial buildings with all glass facades are a commercially viable alternative for owners as well as occupants. The other key point I'm going to talk about with changing energy codes, it is really something you need to look at and really define. And as it was mentioned in a number of the presentations during this session, you need to have a group of individuals involved. It can't be done on a kind of silo type basis. You need to include a number of individuals. So as we get into the facades, why are all glass facades a great design choice? They're very competitive in terms of materials, and Dr. Chung mentioned that early on. You don't get a lot of benefit, if you would, out of daylighting and some of the things that we look at today from a all-clad or a brick building type application. So again, when you have glass, you have natural light coming into the space. That natural light works with the occupants, makes them feel better, they become more productive. And glass type buildings, as we've seen today, give you a higher lease rate. So let's talk about some of the myths. Glass is more expensive than other buildings. That's really not true. So you look at this slide, if you're looking at an all-glass facade, it is very comparable in terms of the cost structure of other types of materials, whether it's faced brick or precast materials. So again, it's very, very comparable. And again, as we go into those applications, yes, it can change. You start getting into the heavier glass wall systems, double skin buildings, triple insulating units. Yes, they're going to be more cost associated with it. But again, when you look at it on a cost per basis with the other materials, you can see that it is very, very cost effective. So thank you, Dr. Chung, for making that comment. Also, when you're looking at glass facades, you're going to increase the amount of daylight coming through that particular space. And we've seen a number of documented studies that talk about the increased productivity that you're going to get from the individuals in that particular structure. And you're going to get a reduction in terms of absenteeism. So again, the most valuable resource that you have in most of our buildings today is the individuals in those buildings. So if they're actually coming to work and they're very productive, you're going to get a return on your investments. Your client is going to be very, very happy. We've also seen that there are health benefits from having natural daylight coming into the space. Recovery times for patients have dramatically increased in terms of the reduction of days in the hospital. So again, it also helps us in reducing some of those depression type things that come into play and improve sleep. So again, as we go through and look at the psyche of the individuals that are working in those spaces, glass helps because we're bringing in natural daylighting. Natural daylighting really is what people are looking for. We've also seen it even on a retail level, where people tend to gravitate towards natural daylighting. And there are a number of studies that have been done that documented where individuals might have, let's say, a standard roofing system in one section, having the same retail material in that section, and having a glass skylight system. Individuals will tend to gravitate to that natural daylighting section. So again, increasing it in terms of retail sales activity. So we can see there are a number of different reasons why glass facades, glass materials are very helpful. We can also look at some of the aspects of allowing more light into the space and connecting into the environment, which people are looking for. So it increases the ability for lease rates in those buildings. We've also seen lease rates go up in terms of percentage like 20%. So the owners, developers are actually getting a very good return on the investment in terms of providing an all-glass facade. Sustainability, again, it is a very important aspect of what we're looking at. Glass is a natural material, and as Mr. Poon said, it is one of the lower carbon footprint type materials that we have today. I should have forewarned you before we got started because there are a lot of slides in this. You better strap yourselves in, buckle up, because we're going to go pretty fast here. So if you have questions, we'll get them at the end. Also, in terms of property values have increased per square meter, and again, I'm not going to go through the exact numbers, you can see that there is extreme value in terms of having all glass facades. It is an important aspect. There's health benefits. There's reasons why people want to use or occupy those spaces. You get productivity increases. And in terms of the owners and developers, there's an extreme return on their investment. And I'm going to go through a few of these things. We'll go through them pretty quick. I'm going to go through them all individually here. First, cost reductions. When you're looking at glass materials, and I've got 3 different sections on here, if you would. If you're looking at double silver, which is kind of the base point, so you're looking at a standard insulating unit, a 612-6. If you're looking at a double silver application, you can see what the first cost is. Now, if we go into some more of the high performance type products, and as I said, the double silver insulating units is really the base point. So now we start going into those triple silver applications. You can see the first cost structure does come down. And again, what we're doing is reducing the amount of heat gain. And typically in a commercial application, and I'm from Minnesota, very similar climate as we have here in Seoul, South Korea, our air conditioning systems on our commercial buildings are running 11 months of the year. So we are more concerned about reducing the heat. So if we can do that, we're going to get a better return on our investment. So again, in terms of Singapore and Seoul, Rod, you can see that that's going to bring down the first cost of the air conditioning system. So if we can save tonnage in that air conditioning system, you're going to get a return on your investment. We can also see it, and I'm going to click through this real quick again, in terms of operational cost. Again, we're looking at double silver, triple silver, and the hybrid coating. So you can see the return that you can get in terms of the operational cost as you're going through the building cycles through that process. So again, you're getting first cost savings by reducing the HVAC system. That's money that goes back right into your client's pocket. We're also getting that return on the investment in terms of reduction of the operational cost of the equipment over time. So again, we need to look at what we're doing in terms of building designs. We need to look at the integration of various products and applications. Not one product is going to be suited for every application. And I'm sure as design professionals, you don't want to limit your palette of choices. So again, with the choices that are available today, you don't have to live with one product or one choice. And we can customize those approaches. So that kind of covers the first part on all glass facades. We're going to talk now a little bit more about the changing energy requirements and codes and what's happening today in terms of energy codes. We're seeing more stringent energy codes come out. And what we're going to do is we're going to talk about going from the progression of the 80s to the 90s to the 2000s to the 2010s and today. So as we looked at the 1980s, what did we see? We saw highly reflective buildings, the very shiny buildings with very low visible light transmission. We also saw those buildings, because they had so little light transmission, were reflecting both the visible light transmission as well as the ultraviolet and infrared. So again, reducing the amount of energy being consumed in those buildings. And in some cases, we're also looking at monolithic glass. As we got into the 90s, it kind of changed. We started to see the movement towards low emissivity coatings. Low emissivity coatings weren't those shiny buildings that we had seen before. They were more transparent. They get more connection, if you will, from the outside. The occupants inside also had more connectivity. You could see through the buildings, into the buildings. They had higher visible light transmission. We started going back to that thought process that natural light was important for us. The drawback, however, in some of those situations was the solar heat gain coefficient or shading coefficient wasn't as effective as we saw with some of the high performance reflective coatings. One of the other things that we did see in the 80s with the high performance reflective coatings, they were great during the day. During the day, very reflective. Individuals inside the space could see out. However, when that situation was reversed at night, dark outside, lights inside the building, they were essentially solar mirrors. So the individuals in the space couldn't see out, but people outside could see in. So again, that gave you kind of an eerie feeling. As we moved into the 2000s, we saw more low-E coatings being used with higher visible light transmissions. We also started seeing hybrid coatings come into play. When I'm talking about hybrid coatings, essentially what they were was to take a high-performance reflective coating, the best attributes of that, and blend that with the best attributes of a low emissivity coating. So essentially what you had was a high-performance product that gave you fairly high light transmission, had some degree of reflectivity to it, but gave you excellent solar performance characteristics. Also, when we were talking about high-performance reflective coatings, those shiny buildings, they did not have very good U or K values. The low emissivity coatings have excellent U values, K values, and that comes from the improvement of the silver products that are on those particular coatings. So these hybrid coatings gave you the benefit of improved high performance, shading coefficient, solar heat gain coefficient, gave you the ability to have some light transmission, excellent K values, U values, but also, as you can see, gave you the ability to have some degree of reflectivity. If you go back and look at some of the, if we can go back to one of the slides, you can see the the low emissivity coatings are very, very transparent. And again, in certain applications, if you don't have direct sunlight on them, they go very dark. They go kind of black. And that's when we start talking about reflected versus transmitted conditions. So again, when you're looking at high performance reflective coatings, they tend to have that shininess and appearance. When you're talking about low emissivity coatings, they are anti-reflective coatings in nature. A typical insulating unit with 6-12-6, no coating on it, clear glass, has an interior and an exterior reflectivity of about 14%. When we added some of our low emissivity coatings, it dropped that reflectivity down to 11 and 12%. So they tended to make that glass go very, very dark in the opening until you dropped a blind, and if you dropped a blind, then you saw the color of the materials. Where the hybrid coatings, because of that degree of reflectivity, you are going to get some sparkle, some life to the glass, but you still get that transparency. And again, you can see that in some of the buildings we have here today. And as I talk through some of these things, we also saw an increase, a huge increase, in the use of low iron glass materials. Typically, the base common denominator for most insulating units is clear glass. However, as we started seeing the influx of various low iron glass materials, it became the product of choice. What essentially it did is you took the iron content out of the glass. So as you take the iron content out of the glass, you're getting more transparency. You're reducing the effectiveness of the glass. So it required more performance from the coatings. But you also got a purer look at the coatings themselves. And again, in the 2000s, we started seeing that improvement in terms of solar heat gain coefficients. What are we seeing today? We're seeing an increase in the requirements for LEED or sustainability and energy performance and daylighting and views. We're also seeing larger openings. And as we see more glass on the buildings or larger openings on the buildings, that's pushing glass fabricators to come up with better products because code requirements are dictating what we are going to do today. So as we start getting into those code requirements pushing us, we are not going to be able to get around those requirements. We are going to have to take them into consideration, and there's a few things that's going to end up happening. We're not going to be able to have these highly transparent buildings anymore, as you see here today, with vast spans of glass on them. The choices are going to end up being you're going to get smaller window-to-wall ratios, or you're going to have to go to more of the hybrid type coatings. Now, as a glass fabricator, I don't want to go to smaller openings. I want you to go to bigger glass, as much glass as possible. So again, what we want to see today is larger glass openings, not restrictions from the code officials saying your window-to-wall ratios need to be smaller or using the prescriptive method. And I can't imagine any building that anyone in this room is going to design is going to use a prescriptive method, but you're going to do energy modeling. And those things tend to help us today. So when we're looking at floor-to-ceiling glass, what do we need to do? We need to balance that view and transparency. We need to take into consideration glare applications, and I'm not going to go into that in great detail. I took that out of the slide. But what are the things that we look at today as design professionals? We look at the window-to-wall ratio. We're looking at the VLT, or the visible light transmission, and the solar heat gain coefficient, as well as U factors. I also took the U factors, K values, out of this presentation so you don't have to worry about them. I'm not going to put you to sleep being a glass geek. But when we start looking at some of these window-to-wall ratios, there is software available today that helps us go through and do the analysis of identifying the optimal solutions in terms of window-to-wall ratios to come up with the best choice. So as we start looking at visible light transmission, you can see here kind of the contrast between visible light transmission. Both of these products that you're looking at here are low emissivity coatings, the same coating. The only difference between the two is the color of the substrate. The one on your right, my left, is actually a gray glass with a, what we call a double silver low E coating. The one on my right, your left, which is clear glass with a double silver low E coating, has 70% light transmission. So what we need to do as an industry is to come up with better solar products. And you're needing to push us to do that performance characteristics. So when we start looking at the window-to-wall ratio, we need to take or have a benchmark or a tool to identify where we should be at. And what we're looking at today is using the effective aperture. The effective aperture essentially is taking the window-to-wall ratio, multiplying it by the visible light transmission. In the case of that one project with a 35% light transmission, the effective aperture is 0.21. Now, Lawrence Berkeley National Lab, and was funded by the Department of Energy, U.S. Department of Energy, came out with some benchmarks as far as goalposts, if you will, of where we should be looking at. Again, these are just goalposts. And the recommendation was we should be between 0.20 and 0.30 in terms of that effective aperture. So again, if you have a larger opening, you're probably going to have to reduce your visible light transmission. If you have a smaller opening, you can probably have a higher light transmitting product. So I'm not going to go into a lot of detail on this, and a lot of this information is on our website. We actually did go out and survey some 5,000 to 6,000 architects to ask them if they understood the window-to-wall ratio concept. And again, here's some of the results that we're looking at. 62%, if you will, we're looking at window-to-wall ratios somewhere in the range of 30 to 60%. We also asked them the question about, do they understand transmission, where they want to be in terms of light transmission. Again, it was kind of a little bit all over the map, but 30 to 60% light transmission was kind of where they tended to gravitate towards. We also asked them the question about solar heat gain coefficient, where they should be looking at, and they were pretty much on spot. 55% were in that 0.26 to 0.37 range. But one thing that really concerned us as an industry was that 26% didn't know. And that, to me, is shame on me as a glass professional not to help them. And those types of things that we are trying to provide today in terms of tools and resources for the architects to go to, whether that's BIM modeling, we're going to be charged with making those things happen. So some of the things that we can do in terms of balancing the design, we can look at thicker glass materials. I have to ask a question here. How many architects do we have in the room? How many architects hate roller wave distortion in your glass? Your glass kind of looks wavy. If you hate that look, what you need to do is increase the thickness of the outboard light. If you do that, it'll make the glass stiffer, thicker. Now, the mechanical engineers out there are going, don't do that, because what it's going to do is going to increase your sightline requirements. But again, if that's what you're looking for in terms of appearance, I would recommend going to a heavier glass outboard. You can also improve the performance of the glass in terms of shading coefficient, glare reduction, by using some of these other techniques, whether that's using silkscreen, tinted glass, or looking at some alternative coatings. As I mentioned, you don't have to just deal with off-the-shelf products. There's a lot of different opportunities. So I've gotten to a point now, you've probably heard me talk enough. I've got about an 8-minute video, and I'll probably cut this off before the bell rings. But the video is going to talk about how some design professionals use various products to get to the performance levels and design techniques that they wanted to use. Now, if everything works well, it should bring the video up. We tried this yesterday and it worked, so. And absolutely doesn't work. Okay, we'll just move on then. Essentially what the video talked about, we had a number of different architects that looked at their buildings, and those building applications, they looked at how they could use daylighting techniques. And those daylighting techniques that they looked at was either using some type of tinted glass materials, looked at using silkscreen applications. So again, giving them a lot of flexibility in terms of their design requirements. We also talked to some daylighting engineers in terms of what they're looking for and the number of foot candles that they are looking at or trying to have come into a space. So those types of things, and that video that I was going to play for you is on our website, so if you ever want to see that video, and hopefully you do, we'll give you a little bit more background in it. But the bottom line, what they're talking through is there's a lot of different things that we can do to glass materials today that will help improve the solar performance characteristics. It will allow you to have, or right size, if you would, the visible light coming into the space, as well as improve your overall performance. We can also do the performance improvements, whether it's a K value, U value, solar heat gain coefficient, reduction in glare applications. Those are the types of techniques that we're currently working on today. So, what are they looking for from a glass material? What are the architects looking for? I have never had an architect ever tell me off the bat, I have a solar heat gain coefficient of this and I want to meet this. The first thing I hear out of their mouth is, what color can I have it? And then we start from that direction. So that's what the architects, at least that I've been dealing with, are looking for. They're looking for an appearance, they're looking for a color. The next question is, how big can you make it? So they want to try and go bigger. As we go bigger in those openings, again, by code, we're probably going to have to reduce the solar heat gain coefficient to meet code, or we're going to have to reduce the size of the lights of the glass. So we're going to have to use some techniques to help us in terms of getting to that solar heat gain coefficient that's required based on the size of the glass. They're also looking at sustainability. That's a given. We're not even going to come to the table if our products aren't sustainable. So again, as a glass fabricator, that's what we're doing every day. We are trying to provide you information, materials, resources that is going to help you in terms of providing whether you need lead points or information related to sustainability. I know that Charles Cliff made mention of that reflectivity tool that they were looking at. I hate to say this, but that building, Vendara in Las Vegas, that's my building. And in the US, they called it the death ray. And we had worked with the architects for a number of years and had suggested they not do what they did, but they chose to do that. So it's not an unknown factor that hasn't happened, and it had happened before. We had another building in Vegas where we put a high-performance reflective coating on it, and it essentially burned a hole in the parking lot. So if you want to create the death ray, I can help you do that. In terms of energy performance, again, our materials have to be energy performance. What are the consultants looking for? I know there's a number of consultants here today, and every time I've come to the consultants, they want to make sure that our products are code compliant. They're looking at improved U values, improved K values. In some cases, when we're looking at the daylighting consultants, they want to try and harvest the natural daylighting. So again, there are things that we can do in terms of providing products and solutions that are going to help you harvest daylight, bring light into the space, but push it further back into the space. Essentially what you're losing if you're just allowing all that light to come into that small area right next to the windows, we want to push it further back in the space. So there's techniques that we can use today to help you do that. We also have to be cost effective. I have to deal with every day, as you do, value engineering. I don't think I've ever had that term value engineering happen. It's cost cutting. There are a couple of projects we have seen value engineering that actually something positive came out of it. What are owners and developers looking for? Something that's cost effective. They're looking at trying to reduce first costs, putting money back in their pocket, and that's what we try and do today. We're trying to reduce the operating cost of the building itself. As we talked about today, buildings in this high-rise environment are going to be here for a long, extended period of time. And what has happened in our industry as a glass fabricator, the performance of our products in the last 5 years have taken quantum leaps forward. So a building that had a coated product 10 years ago, if that were replaced with an advanced coating today, you could save about 40% on your operating costs. And again, those types of materials are available today. As design professionals, you're going to push us to get better, and we need to do that. As owners, developers, you're going to want to have better products, better materials. So again, we need to know what you need to have in order for us to get better. What are they also looking at? Higher lease rates, improved productivity, and occupant comfort. So I hope what you've gotten out of this presentation is that all glass facades are a great commercial application. That is good for buildings as well as owners and developers. We can help you get to code compliance. You don't have to settle for just off-the-shelf products. You can still have large expanses of glass and still meet the performance criteria that's required in terms of energy conservation. So, in closing, rather than making it a question, I'm making it a statement. Glass, if some is good, more is better. Thank you. Any questions?
Thank you, Don. Your presentation was excellent. That's what we need to know. And also, when I go back to the United States, I will include, among my structure courses, I will include glass structures. It's kind of a hidden subject in the structural education. Any question for Don? Yes?
Thank you. I have a question regarding the ceramic frit paint that you can use on the outer layer of the glass. How does it improve the solar heat gain or the visibility? Do you recommend that? For what kind of weathers? And what is the cost relation about adding that feature against, I don't know, a higher quality or maybe a higher solar heat gain coefficient for glass? Like, what is the cost relation?
Okay. Hopefully everybody heard the question. It was related to ceramic frit. Typically, and I'm going to say typically, we use our ceramic frit on the number 2 surface or the number 3 surface of a standard insulating unit. We don't put our frits on number 1. I know in Europe they do number 1 surface frits. We just don't feel that our paints currently are durable enough. What ends up happening as we apply that ceramic frit, and we can do it in multiple colors, we can do it in multiple designs. You don't have to just stay with let's say a dot pattern. We've seen an increased interest in using graduated patterns just like on the windscreens of your car. What essentially happens is let's say it's a dot pattern, it'll absorb that infrared heat and reject the heat out of the building. What we can also do is provide a high performance coating, whether that be a hybrid coating or a low emissivity coating, right over the backside of that silkscreen design. So we have our outboard lighted glass. Behind that, we have our silkscreen materials, and then behind that silkscreen on the number 2 surface, we can put a coating on it. So the coating is acting as a screen, the silkscreen is acting as a screen and absorbing that infrared and redirects that heat out of the space. That's where we're getting that solar improvement. In terms of cost effectiveness, the cost of those types of materials are coming down. I would say you're probably looking at a 15 to 20% increase in the cost of using a ceramic frit. There are some alternate coatings you can look at, but as I mentioned, we've seen a lot of interest in graduated silkscreen designs or patterns on the glass, where if you're looking at a coating, the coating is probably going to cover the entire surface, where the silkscreen designs you can kind of change it. But there are coatings, yes, you could use a different type of coating, but a lot of the coatings that we're using today, as we put on heavier coatings, are going to add color to the glass. You can also use alternative colored substrates. I'm going to put my Viracon hat on. Currently today we offer 29 different substrates. So if you wanted a glass that was green or gray or bronze or blue or charcoal or whatever, we can mix and match the coatings that we offer, and we offer about 35 of those coatings today on 29 different substrates, and I'll let you do the math. And if you're looking at silkscreen design, we have virtually an unlimited number of choices of silkscreen designs. Whatever you can create in a CAD file, we can create in our labs. So hopefully that answered your question. Any other questions? Yes, sir.
Double silver, that's
Mark, you can't ask any questions last night. I had a dinner with Mark, so he can't ask any questions.
Well, hi, Don. I haven't heard of double silver, triple silver. Is that industry lingo?
Question was, is double silver, triple silver industry lingo? It is somewhat. For my product offering, I tried to keep this very generic. I could have used different product connotations, but the first generation of low emissivity coatings came out. That was a single layer of silver. Then you saw in the 80s and the 90s the second layer of silver coming onto the glass, so that's why we call it double silver. And just recently, within the last 3 to 5 years, you saw the third layer of silver coming into play. So that's the kind of progression, if you would, of performance products by adding silver, which is the workhorse of a low emissivity coating, to the glass material. So.
I see. Then one other question. On a standard pane that might be 5 foot by 6 foot vision glass, what would the thickness need to be to not have pillowy effect?
I'm sure you heard the question, 5 to 6 foot range, if you will, let's say 1.5 meters by 1.8 roughly. I'd have to ask you a question back, and that question would be, what's the framing system? What's the wind loading? And then I could answer that question. Typically, I would say in that particular situation, if you were down, let's say, on the ground floor level and you're not getting high wind load application.
No, it's a 50-story building.
50-story. At the top? Okay.
No, all over the place.
All over the place?
The owner doesn't want any pillowy effect on
okay.
the
Then what I would say what you want to do, Mark, is you probably want to go to 8 or 10 millimeter glass, because that glass will be stiffer. And being stiffer, it's not going to deflect as much, so it is going to look flatter. If you will, the poster child of doing that is 7 World Trade Center. That is one of the buildings that used low iron glass materials, used a high performance reflective coating, used stainless steel air spacers, heavier outboard lights of glass. I can't tell you the exact configuration of the makeup, otherwise I'd have to shoot you because we can't divulge that information. But the outboard light was a heavier light of glass, and you get less deflection in the glass materials. If you do have 6 millimeter glass and you have very high wind loads, it might make it from a structural application, but I will guarantee you it'll start to pillow.
Do many of your customers purchase 8 millimeter outboard glass?
We are starting to see an increased trend in people buying heavier glass as we get into the larger openings. Just for this, what you mentioned, you're trying to keep it from pillowing. So that is one of the trends we're starting to see. The other thing that we are seeing is an increased use, and depending on the location in the world, of laminated glass outboard, whether that be for fallout protection or some type of blast mitigation or some type of protective glazing situations. If we were looking at, let's say, a laminated glass as an outboard situation where you have 2 lights of glass and there's an inner layer, we would coat the number 4 surface of that because we'd have an airspace behind it and then a light of glass. So in a typical makeup, a typical insulating makeup, you're probably getting a 6-12-6, we would coat number 2. But when you're using a laminated outboard, then we would go number 4.
Sorry, Don.
Yep.
Sorry for interruption. Time is running. You two get together at the lunchtime or tonight. You spend all night long for the subject, okay?
Well, Mark, I'll buy you another glass of wine at dinner, and then we'll have a bottle or two. Thank you very much.
Let's move on to the next speaker.